Hi, everybody. It's week 2 in astronomy, and let's talk about the chapter. Let's talk about the lab, and let's talk a little bit about light. So, this week is all about light, and light is so exciting because everything we get from outer space, all the information we get about stars and galaxies and solar systems, comes from the light. And we're not talking just visible light, we're talking about infrared, ultraviolet, X-ray, gamma rays. And so this whole chapter is about light. It is a fabulous one of my favorite topics in all of science. And it applies to the light bulbs that you buy at the store, to the light that is used to x-ray your body. It is throughout the entire semester. We're going to use the information that we talk about today. And I hope you find it one of your fun pieces of information, that one of your fun lessons for the entire semester. So let's wander over to Canvas and take an overview of the week. So we're going to begin with kind of an overview of our week on light. And as we have talked about in the past, if you would like a copy of the PowerPoint notes that I use for my lectures, download those here. I'll quit reminding you some of these things when we're a couple weeks in. Some notes on light and color, some great supplemental videos that I really would like you to watch because I include those so I don't have to say some things. Property of all of these electromagnetic waves, they're all the same. They just happen to be different sizes. And then we go into a discussion of these different kinds of electromagnetic waves. Now, there is a study guide for every chapter. These are reading guides, and sometimes students lose track of what's the purpose of the reading guides. I cannot, in a couple hours of lecture, show you all of the information that is out there. So this is to help you read through that textbook. These are keyed directly to the book, and when you're done, submit these through Canvas. And you can do those as you go through the assignment, or you can do them as a review at the end. Everything we know about stars we get from the light we receive from them. Different colored stars are different temperatures. How do you take how do you find the chemistry? How do we know some stars are more hydrogen? Some stars contain heavier elements like calcium and fluorine and sodium. That all has to do from the light. A different spectra. What do we mean by stellar spectra? And that is actually, we're going to explore that when we get into our lab this week. The Doppler effect. The Doppler effect, important in astronomy, incredibly important. This helps us determine how far away stars and galaxies are and how fast they are moving away from us or towards us. And some fun videos to help illustrate that point. Now, when you get to this light lab, download this file and then open this file, the emission spectra for gases, online so that you can look at it. You don't have to print it, but please look at it. So let's take a look at this week's lab. I'm going to ask you to do a couple things. For the lab this week, I'm going to ask you to write in the various kinds of electromagnetic waves from the long wavelength to the short wavelength. Remember, all those L's go together: long, low, and long energy, low frequency, and long wavelength go together. Answer some questions about this, so kind of review the information that you have learned through the notes. Then I'm going to send you off to a simulation, another one of the simulations from the University of Nebraska, and this is talking about blackbody radiators and blackbody emitters. The peak of the blackbody curve given off by a star is related to the color that star appears, and tells us an awful lot about the star itself. So I'm going to ask you to look at this diagram, draw a line straight down from that peak, and determine that dominant color and dominant wavelength. Go to this simulation. Remember, if you have any challenge opening these simulations from UNL, University of Nebraska at Lincoln, you may have to change browsers. Personally, if I'm in Chrome, I have to copy this, go into something like Microsoft Explorer, copy, paste it, and actually I right now have 2 browsers open on my computer. When you open this simulation, it is going to look something like this. And I can change the temperature of my star up here. And then the peak of that curve, you can go straight down, and that is going to be the dominant wavelength, and that's going to be the dominant temperature. And you can see this. So when this is a hot temperature, this is going to be well above visible violet. When I make this a cold star, the peak is going to be much cooler and below infrared. And you can see these relationships between the peak of the curve and the color that that star appears. When you go back to our lab, I'm going to ask you to take a look at these different peak temperatures. Do this in the simulation, and then use this piece of information down here to relate that to the color of the star. This is a chart where we're going to refer to lots and lots and lots. Stars come in different classes, and the classes are the letter O, B, A, F, G, K, and M. And we will talk about those more when we go into more detail of stars in later lessons, but I want you to start getting used to this. Color is related to temperature, is related to class of star. So we're just beginning to learn about that information. Now let's talk about some very important bright stars, Aldebaran and Sirius. I want you to look those up on Google or your favorite browser, figure out what constellation they're in, and then label them on these 2 constellations. Let's talk about light bulbs. When you go down to your favorite store and buy an LED light bulb, on the light bulb box, there will be a temperature, which is weird because 7,000 Kelvin is crazy hot. Your light bulbs are never going to get that crazy hot, but it relates to the color of the light. And this all relates back to the peak of the Blackbody curve. So you might say, what does this have to do with life? Well, it has to do with the color light bulbs you're going to buy. And I want you to relate that back to what you see and what your light bulbs are going to say. If you have a challenge seeing colors, please enlist the help of a friend or a colleague or a neighbor to just see which color is which on the photographs. Now, type of spectra. In the lessons, we talked a lot about spectral type. And I'd like you to watch this little YouTube video. It is done by a university where they actually show you how spectra are viewed for different elements. And that's the other file I wanted you to download from the lab. You are going to use this as a key when you are identifying some elements just by using the spectra. Remember, every single element out there has a unique spectra or fingerprint. And this video is going to show you how those are actually found. Then I want you to go to another one of the simulations at UNL, University of Nebraska at Lincoln. And in this simulation, I want you to look at continuous spectra and then emission spectra of different elements, helium, hydrogen, different metals, and see what's different between an absorption spectra and an emission spectra, because they don't look the same. And this is all important information for our upcoming quiz. Next, identifying elements. So we've talked a lot about light. We've talked a lot about emission and absorption spectra. So here are a spectra from 1 to 3 different elements. You get to play the scientist. You have observed 1, 2, 3 different elements. These are the spectra, and your quest is to identify these 3 elements using just the pictures. Now, again, if you have a challenge seeing color, please enlist an associate or a friend or a family member to help you see these. How are you going to determine this? Well, that's what this file is all about. This is these are your possibilities. Treat this like a multiple choice question. And the 3 I gave you will be one of these on this page. So it's not an infinite choice. These are your only choices. And identify these using that picture. And you can figure it out. It's not too bad. A note about these. On the lab itself, you're going to see little point values. That is how much this section of the lab is worth. Every lab is worth 20 points. And so identifying these 3 accurately is worth 5 points. That's a quarter of the lab. So please take this seriously. Last but not least, in this week's lab, I want you to do some investigation of the Doppler effect. Again, we're going to go to a simulation. This one is from a different source, not the University of Nebraska. When you go to this simulation, you're going to move a little spaceship and have him go towards a planet, and you are going to see how wavelengths change depending upon if you are moving towards or away from a source. And so that is what this is all about. And when you are all done with that, I'm going to ask you to count how many peaks fill in the observation box. And when I say the observation box, I'm talking about the box down here. How many peaks will fill that in? And then I'm going to ask you to sketch what it looks like when it's not moving, approaching, moving away, approaching, then moving away, and then I want you to do something crazy and having both things in motion. I want you to answer a few questions. When you're all done, woohoo, you are done with another lab. If you have any questions, please go back to how to submit your lab reports, and as always, email me if you got some questions or whatever. Have a fabulous, fabulous week. Light is so interesting and such an important part of all of our lives. And I hope your eyes are open about the different kinds of light that are out there. The infrared, the microwaves, everything from your cell phone to AM radio is all the same stuff. It's just different sizes. So talk to you soon. Have a grand week. Bye-bye.